So chemical reactions require what? Energy comes in the form of... All right, so we need to partition ourselves into the correct location. So if you're an electron transport chain protein, where do you put yourself? If this is the membrane separating the matrix from the intermembrane space?
Where is it?
Good. Right there. So imagine this concrete is the phospholipid bilayer. Right? You guys can spread out enough that you can have space, but you can reach each other with your hands. So you can pass something. Yes, perfect. Nice, great. So, because you'll be passing what along the electrons? All right. So now in the matrix, we have the chemical reactions collectively known as the Krebs cycle or the citric acid cycle. So Krebs cycle, you're in the matrix. And how about if we have you
What's in the...
just sort of streamlining sake, stand right over here. Perfect. So in the intermembrane space is one of the reactions of cell respiration called starts with P. Pyruvate oxidation. So where are you? All right. So you can stand right here. Perfect. Excellent. Glucose. You're not here yet. So you can stand over the sun over there. Sorry. Likewise, all the oxygens, we're holding our breath. You guys haven't come in yet, so you can sort of stand over there also. Okay, so the NAD pluses are the electron carriers that don't have electrons yet. So you're going to get the bulk of the NADH will be made in the Krebs cycle. So you NAD pluses can sort of head over and hang out around the Krebs cycle, hoping for a handout.
You're asking too much here.
Now, glycolysis, you are in the cytoplasm. So you're going to head out over there to the cytoplasm. Protons, they're an ion, so they can't freely cross the membrane, so it'd be tough for you to be standing where you are, right in the hydrophobic part. So how about if we have you protons? And this is a bit of a, it's totally realistic. We'll have all you protons start over in the matrix. Okay? The protons will go to the matrix. All right, all you ATPs, you don't yet have your energy, so you're, flip your sign. Your ATP. Now, there needs to be one other very important player in the membrane. Very good. So the ATP synthase is a membrane protein that lets what cross? Protons. All right. So you protons, you could flow back and forth either way. So if there's an excess of protons, as soon as you guys, there's 6 of you, as soon as there's an excess, meaning 4 and 2, in the intermembrane space or in the matrix, one of you will walk past ATP synthase. As you do that, ATP synthase will rotate. Show us. And as you rotate, can you come over here? As you rotate, you will flip an ADP to an ATP. Very good. Perfect. Okay? Let's see if there's anything else we need to do. All right, so the other, so ADP, as soon as you guys are in the form ATP, you're now energy. It can be used by the cell. So as soon as you're over by ATP synthase and he turns you into ATP, you walk back over to the cytoplasm where the cell reactions are occurring, and you flip yourself back to ADP, and then you walk right back to ATP synthase, and if a proton flows past it, you get turned back into ATP. So your job is to shuttle back and forth between the cell reactions and ATP synthase. Does that make sense? Now, glucose. So the very unrealistic thing that we have to do in this experiment is we have to have glucose run through the whole cycle, and you would actually be, all your carbons would be released as what? Where do all the carbons in the glucose go? Oh, come on. You breathe in what? You breathe out what? Carbon dioxide. So we don't have a way to simulate the release of carbon dioxide. So we can't simulate that. We could figure out a way. But you have to go through the cycle, give your electrons to the Krebs cycle, and then you have to go back and become glucose. So that's unrealistic. But you're just going to have to cycle back and forth. Walk through glycolysis, get turned into pyruvate, go to pyruvate oxidation, become acetyl-CoA, go to the Krebs cycle, you get your electrons, and you'd be evaporated into carbon dioxide. So, shall we walk through one cycle, and then I'll set you guys free to respirate. So, first thing we're going to do is we're going to take a deep breath. And then the oxygens will diffuse into the matrix of the mitochondria. So diffuse oxygen. I should have you randomly bounce around. Okay. Now, since I know you guys typically wake up and have a Monster or a Rockstar or something for breakfast, glucose is a perfect food. So glucose will come into glycolysis.
Yeah.
And get turned into
mine's deactivated.
pyruvate. And then you come to the pyruvate oxidation.
Yeah, and then I'm like,
and get turned into acetyl-CoA. You can breathe out. Maybe simulate the loss of carbon. Alright? Then you'll come in. Well, the pennies will come. You'll come to the Krebs cycle. And you will give your pennies to Krebs. Now, there's many elements of this we can't simulate perfectly. Let's have a look at give Krebs cycle. So now,
it's not going to be a really big surprise that I'm going
no. Just like a point of that, But you know, a lot of people kind of like, either they make their lives sound worse than it really is on Facebook, or better. And usually, if it's not that bad, then it's pretty bad.
So you come up to the electron transport chain, give them your pennies, and now you become one. And AT plus. Now, if the Krebs cycle has more electrons to give, then you would give those to the NAD plus and shuttle it back and forth. So you now are going to pass them. Now, as you pass electrons,
I follow a lot
also
of
going to take a proton,
like fitness
one
stuff.
over,
Sometimes it's motivating, and other times it's like.
and then move the proton across the membrane. So now you are in the intermembrane space. So you're going to take these electrons, you're going to pass them, and as you pass them, grab a proton and move that one across. Okay. And then you're going to do the same.
Where did you go to high school?
So now, at the end of the electron transport chain, we need somebody to give these electrons to. So who gets the electron? Oxygen. So an oxygen, come up here. Perfect. Get the electrons, and now you become water. All right. Now, once you're water, the only way you can turn back into oxygen is if a plant takes you in and makes you oxygen. So you're stuck as water.
What do you
So at this point, we have 3 protons and 3 protons. So let's did we just do one set of electrons? So why don't we do one more set?
I just kind of like,
do you write it down?
Now, proton.
come on over.
So at this moment, now we have an excess of proton. So this is another part of the simulation that is slightly inaccurate, but it's all right. You will flow past ATP synthase, and as you flow, you spin, and you're going to grab an ADP and turn you to ATP. Okay, so now we just completed the synthesis of some ATP. Does everybody understand their role? Let's reset everything back to 0. So you can give your electrons back to glucose. And protons can go back in. Oxygens can redisperse, rediffuse. And then we're going to run the simulation until we run out of some essential part of it. And we're going to see where that causes a problem. Okay? So let's go ahead and take a deep breath. The oxygen diffuses in. Then
And then I also look at
we'll take a
pictures
sip of
of
red
their last
Red
life.
Bull. Alright.
It's like you don't know exactly what she wants us to.
Glycolysis not being very lively.
Yeah, everything that you see. Share your kids.
Alright, so just keep running. Glucose, you can go back and become glucose again. So now,
What is it? What is she
2 pennies to NAD+. Become NADH.
Name notch.
Flip it. Yep. Now flip it back. Good.
UK. You mentioned UK. There we go. This fine.
Alright, so keep running.
Book.
Keep going in. Keep going.
And then they get
So oxygen, what did you become when you got this life?
But my mom, especially. I was like,
and then here she might write something about
So make sure you become So you go over to the reactions with the cell and
Do not continue.
so you can come back and get ready to get another. So come on.
I do a lot of books that have like
So you guys gotta keep moving back and forth.
I wonder if it's helpful that way or the way that
when I write things, that's why I'm
probably why. Because I used to do Yeah. That's what I'm trying to do, like eat more, not be greedy. But like I don't know which one helps next.
Oh no! The electron transport chain is looking for somebody. Who are you looking for? And what do you find? So what happens? Right? We can't do cell respiration if there's no place for electrons to go during the electron transport chain. So there's basically a bottleneck in the electron flow because there's no oxygen left. And so we cease doing cell respiration. Now we could shift over and start doing fermentation in order to generate some ATP because we need ATP for the reaction of the cell. But there's no oxygen, there's nowhere those electrons to go. And I know it's nice to be rich, but you need somewhere to deposit them. Okay, so let's go ahead and reset everything. And then I'm going to play some other roles.